Welcome to The Explainer. Today, we're going to try and completely reframe how you think about artificial intelligence. Seriously, forget the futuristic robots and sentient computers for just a minute. What if I told you AI is a tool we've actually been using for thousands of years?
Okay, let's just jump right in with this really provocative idea from economist Thomas Sargent. He's basically saying that the founders of modern science, we're talking Copernicus, Darwin, the whole crew, were using what we should be calling artificial intelligence. Now, to get why he's saying that, we need a totally new definition of AI.
So, to really get on board with his point, we have to understand what Sargent even means by intelligence. He's not thinking about consciousness or feelings. For him, it's about a set of very specific jobs that our brains do. And he boils it down to these three things. First up, pattern recognition. Think about it. Your senses are just flooded with raw data all the time. But you don't see a million colored pixels, you see a dog. You compress the data. Second, there's generalization. You take a pattern from the past, like the sun rising, and you just kind of trust it's going to happen again tomorrow. And third, decision-making. Based on all those patterns and generalizations, you decide what to do.
So, if you use that definition, AI is just a machine, any device made by us that can do one or more of those jobs. See? It's not about thinking like a person. It's about doing one of these core tasks of intelligence. And honestly, that simple little shift in perspective, it's the key to this whole idea.
All right, with that new definition locked in, let's take a trip. We're going back almost 2,000 years to meet one of the very first masters of AI. He didn't have a silicon chip, but man, did he have a big data problem and one heck of an algorithm to crack it.
Meet Ptolemy. He's an astronomer living in ancient Alexandria. And for ages, people had been staring at the night sky, tracking those 5 wandering stars, what we call planets. Ptolemy basically inherited the ancient world's biggest, messiest spreadsheet, just full of data on where these planets showed up night after night.
The raw numbers were just chaos. So he built a machine, not a physical one, but a mathematical model to compress all that data. He put the Earth in the middle and came up with this system of planets moving in circles that were themselves moving on other circles. It was pure pattern recognition on a cosmic scale, and it let him boil down a ton of data into a model that could actually make predictions.
Now, fast forward 1,500 years, Copernicus comes along with a new model. And here is the absolutely wild part. His model, the one with the sun at the center, it was actually less accurate than Ptolemy's model. The data fit was worse. So why did it win? Well, because it was way simpler. It only used about 36 moving parts instead of 250, and scientists just found that simplicity more beautiful, more elegant.
And this brings up a huge question that honestly still haunts AI today. Was Plato's goal to perfectly describe the data, to build a machine that could predict where Mars was going to be? Or was Copernicus trying to explain the fundamental truth of the universe? That tension between describing perfectly and truly explaining, that's what this is all about.
But this whole process, data, compression, generalization, it didn't just stop with the planets. It turns out this was the secret sauce that powered the rest of the scientific revolution.
I mean, you've got Johannes Kepler. He looked at Copernicus's model and was like, the data fit is a little sloppy. So he swapped out the perfect circles for ellipses, and bam, the model worked beautifully. And that's how we got his laws of planetary motion. Then there's Galileo. He literally made his own data by rolling balls down a ramp, figured out how to fit a curve to it, and discovered the law of constant acceleration. These weren't just flashes of insight. This was straight-up data mining.
And what about Charles Darwin? He spent decades gathering a massive data set of observations. He had all the pieces for his theory, but he was missing the key mechanism. How does selection actually work in nature? He found the answer by watching his own pigeons and by reading economists like Adam Smith, who wrote about competition. He was basically running a machine learning experiment in his head.
Okay, so let's fast forward to right now. If you pop the hood on our most advanced AI systems, you're not going to find some magical new form of consciousness. Nope. You're going to find the exact same tools we've been talking about, just amped up with a whole lot of computing power.
Take AlphaGo, the AI that famously beat the world's best Go player. What's it made of? Well, it's this amazing mashup of ideas. It's got game theory and ideas about prices from economics, Monte Carlo simulations from physics, and yes, survival of the fittest from biology. It's a direct descendant of the thinking that kicked off the scientific revolution.
And this whole concept isn't even that new. Way back in the 70s, a computer scientist named John Holland was already trying to build an artificial brain. He created something he called a genetic algorithm, which basically let a computer program learn through evolution.
And how his system learned is just incredible. He would represent simple rules, like if this happens, then do that, as strings of ones and zeros, like artificial DNA. The computer would test the rules. The ones that didn't work so well, they'd get killed off. But the successful ones, they got to marry each other, combining their code to create new offspring rules. His AI was literally evolving to get smarter. Okay, so all of this history brings us right back to that big, central philosophical question. What can AI really do, and what can't it? Where does modern AI fall on that line between describing and explaining? The great physicist Richard Feynman had this absolutely brilliant analogy for it. He said, imagine you know nothing about chess, zero, and you get to watch two grandmasters play just one game, and you write down every single move.
So the crucial question is this. Just from watching that stream of data, all those moves, could you figure out the fundamental rules? Could you work out that a bishop only moves on a diagonal, or the weird L-shaped move that a knight makes? That's what a scientist like Feynman does. They try to figure out the laws of nature by watching what happens.
And that right there is the perfect illustration of AI today. It is unbelievably, fantastically good at watching the game and describing the moves. It can spot patterns we'd never see, predict the next move with scary accuracy, and play better than any human. But it has a really hard time inferring the rules from scratch. It describes what's happening, but it doesn't yet truly explain why.
And maybe that's the bottom line. There's a huge difference between perfect prediction and true understanding. Sargent himself summed it up with this really beautiful personal thought. An AI can learn everything there is to know about the past, but true human intelligence, the kind his wife Carolyn has, can still surprise you.
So as we look to the future, the real question isn't just about AI getting smarter, it's about us. As these incredibly powerful tools give us better and better descriptions of our world, from markets to weather to our own biology, how much are we going to care if they can't give us that fundamental why? That's the ancient question that we are still grappling with today.